So we can actually transform rational functions. Your basic rational function is y equals 1 over x. We learned it when we did library of functions. Sorry, I just realized that wasn't in the camera. Sorry. So we're going to learn how to graph by transforming. And we already learned this one previously when we learned our different library of functions that's in the back page of your book. So this one we talked about has a vertical asymptote at 0, which makes sense, doesn't it? What's the degree? Wait, what would make the denominator 0? 0. And it has a horizontal asymptote at 0. Now let's think about what we just learned about that. What's the degree of the numerator? It's actually 0 because there's no x's at all. What's the degree of the denominator? 1, because there's no exponent, but there's like an assumed imaginary invisible 1 or something, right? So it would be degree 0 over degree 1, and so if the degree on top is less than the bottom, then the asymptote's at 0. Correct? Yes. All right. So there's that graph, and then there's this other graph that we haven't talked about before. Oh, I didn't actually finish the graph. My bad. So I drew in the asymptotes, and it looks like that. Because if you plug in positive numbers, all this is doing the reciprocal of those numbers. So if you plug in positive numbers, you get positive reciprocals. And if you plug in negative numbers, you get negative reciprocals, right? So if you plug in a very small positive number, you flip it over and you get a big number. You plug in a large number and you flip it over, you get a small number. And that's what causes this shape to happen. Okay? What about this one? How is this one going to be slightly different? What is the squared going to do to the negatives? The squared is going to make all negatives positive. So it would look more like that, right? Okay, now let's transform. I did little red lines. It's the same places. They're the same place. Okay. Transform. Y equals a 1 over x minus h plus k. Or actually, more reasonably, the way you'll see it is like a over x minus h plus k. So the h value is in the, sorry, I was thinking wrong. But either way is correct. It's just that this is the way you're going to see it on your assignment, okay? So a stretches it. You're not going to be able to really see stretches very well in these problems. So you really can ignore a. It does do something, but just ignore it, okay? Because it's very minimal what it does, the stretching. You can't even really tell. Okay, but what does the h do? Left, the opposite direction. This has been the same for everything we've done so far. What does the k do? Up or down, just the number it is, right? We've learned this how many times now? 2 or 3 times? This is probably at least the 3rd. Okay, so let's look at some examples. I wanted to graph. Oh, and is the same thing going to work for this one? It's just that it's going to be the slightly different shape, okay? The best way to transform these is to actually move the asymptotes and then draw your graph. Okay, so let's think of it that way. Move asymptotes, then draw graph. And there is one thing I didn't mention on here, and what would that be? What if a is negative? I guess you can ignore a unless it's negative, because then what will it do? Upside down. Okay. So, example. How about this one? G of x equals 2 over x plus 2 squared. graph that for me. Now I didn't actually write out these for the squared graph, but just keep in mind the graph looks like this. The graph looks like this. The problem we're doing is this. And we just need to move the asymptotes to graph it. So left 2. Ding, ding, ding. You're the winner. Okay, if it's just moving left 2 and it's not moving up or down, is the horizontal asymptote going to move? Nope, it will stay right there. Now, since it's squared, is that going to change whether it moves left or right at all? No, the squared only affects the shape of the graph, or where the shape is located in this case, which just means it's going to be above because of the positive thing. So there's the graph. Yeah. Let me see. I guess I could just make something up. Oh, this one's a little bit weird. F of x equals 1 plus... I was going to do... Here, I'll do this one. This is a better one. 2 minus, that's a minus. Okay, sorry, it's messy. 2 minus 1 over x plus 1. Now, remember how when I was talking about this, I put the k over here? In math, does it matter what order you add things in? No. So even though the k is adding over there, if it's right there instead, does that matter? No. So you can just think of this as, if it's easier for you, think of it as negative 1 over x plus 1 plus 2. It just means the exact same thing. Okay, so what does the negative do to the graph? It will flip it upside down, but we can't do that till we're graphing the actual graph at the end. The first thing we ought to do is move the asymptotes. So where are the asymptotes going to move to? Left 1, good. And what about this one? Not right 2. Up 2. Okay, so normally our graph would be positive, positive, negative, negative. What does that negative do to it? Flips it around, so that instead of going over x is positive, up y is positive, and over left x is negative, y is negative, it will be the opposite. So it will be this corner and this corner. See how I don't even care about exactly where the points are? I'm just using the asymptotes to draw it. Do you see how I'm using the asymptotes to draw it? Okay. Now section 5.3 that we will do next week is using the same stuff we've learned today. It's just that we're going to learn to graph much more complicated problems. And we're going to use like asymptotes and intercepts and symmetry and all that stuff to do the graphing. So today all you have to do is answer simple questions like domain, vertical asymptotes, horizontal asymptotes, graph the transformation. Next time you'll be doing mega problems where it says find this, find this, find this, find this, find this, find this, graph the whole problem. Okay? So this is the easier of the two, although the longer of the two. Sorry you're having homework over the weekend. Actually, if you do it tonight, it's not the weekend yet. It's done. But I'm afraid you will all go, oh, it's not due till Monday.
Could you help us out because it's a holiday weekend? And I have to please. Okay. Me too.
You have to what?
Sing at the Grizzlies game.